There are many different ways of solving quadratics to find the roots of the equation, and the one that we're going to explore here is actually using square roots with just algebra manipulation. Obviously, you can factor using conventional methods or the quadratic formula, but for this one, we're going to actually solve it using square roots. So over here we have 7 plus 4x squared equals 23. And I need to isolate the x, so when I subtract 7 from both sides, I'm going to get 4x squared equals 16. The next step to getting the x by itself, I'll divide both sides by 4. And finally, we get x squared equals 4. Now, we're not done. Obviously, we need to know what the roots are, and this is a square term, so we're able to take the square root of both sides. So the square root of x squared is just going to be x. But when I take the square root of 4, 2 times 2 equals 4. But also minus 2 times minus 2 is going to equal 4. So the roots of this are going to be both 2, and x can also be minus 2. In this example, you'll see that this is not necessarily in the form where I can just subtract 36 from both sides and get a quadratic that I can then factor. I would have to distribute, and I would also have to square this term. And it's not just x being squared, but rather x plus 2 being squared. The first thing I want to do is divide both sides by 4. So when I do that, I'm going to get x plus 2 squared equals 9. And both sides here are a perfect square. If I was to take the square root of both sides here, what I would get is x plus 2 equals positive 3, and x plus 2 equals negative 3. Because on this side, the square root of 9 can be both positive and negative 3. Hence, I need two separate equations. And now I just solve these for x. I subtract, on this one, subtract 2 from both sides. So my first solution, I'm going to get x equals 1. And over here for the second solution, I'll subtract 2 from both sides, and that will yield x equals minus 5. So first, I'm going to divide both sides by 5. And then I'm going to get x plus 3 squared equals 7. Right here at this point, you're saying to yourself, well, if I take the square root of both sides, I'm going to have the square root of 7, and square root of 7 is not a perfect square. So what I'm going to do is I am going to take the square root of both sides, and what I get is x plus 3 equals positive rad 7, and x plus 3 equals negative rad 7. The next thing that I need to do is move the 3 to the other side. When I do that, one of my solutions is going to be minus 3 plus radical 7. And over here, I'm going to have x equals minus 3 minus rad 7. And these are the two solutions. Okay, on this problem, there are two differences. First, there's something being subtracted here, and inside I don't have just something like an x minus 2 or x plus 1. What I have is something that's going to create a two-step equation on the last step. It's not that much more difficult. And the first thing that I do is I add 31 to both sides. I go left to right, bring down everything I didn't use. And then to get this part by itself, I need to divide both sides by 4. So now what we're up to is we have 4x minus 10 that expression squared equals, and 4 on this side. And this one is going to be fairly easy. If I take the square root of both sides, what I'm going to get is 4x minus 10 equals positive 2. I'm going to put the plus there, and 4x minus 10 equals negative 2. Now it's a two-step equation, so I'll solve it first by adding 10 to both sides on both of them. On the left, bringing down the 4x, I have 12. Dividing both sides by 4, I get x equals 3. And on this side, I bring down the 4x. You have a 0 pair, and I have plus 8. And I divide both sides by 4, and I get x equals 2. So those are my two solutions. If I wanted to take the square root of fraction, that's the same as taking the square root of the numerator divided by the square root of the denominator. So for this case, we would have 8 times 8 is 64, and 3 times 3 is 9. So I would, there would be pluses and minuses for this one, just giving an example. So for this example, we'll proceed by adding 11 to both sides. So I'm going to get 4 times 7 minus 4x squared equals 25. Now I have to divide both sides by 4. And that's going to give me 7 minus 4x squared equals 25 over 4. I don't want to divide this, but what I have to do is I have to take the square root of this side to get rid of the fact that this is a binomial that's going to be squared. So when I take the square root of both sides, what I'm going to have is 7 minus 4x equals the square root of 25 over the square root of 4, and the square root of 25 is 5, and the square root of 4 is 2. And then for our second solution over here, we would have 7 minus 4x equals minus 5 halves. Now, the next part is I need to subtract 7 from both sides, and this side it's easy to do because it's a whole number, but if I'm subtracting 7 from a fraction, I need to turn this into 14 over 2, which is still 7, but it'll allow me to do the subtraction given that we have a denominator of 2. So I'm going to subtract 7 on this side, and I'm going to subtract 14 over 2 on this side, which will give us minus 4x equals, and signs are different. Subtract, keep the sign of the bigger one, over 2. And now this last step, I don't want to divide by minus 4 because we have a fraction over here that would get messy. So what I'm going to do, think about this as I'm just going to multiply by the inverse. So I have minus 1/4. So I'm going to multiply by minus 1/4. So x is going to be equal to a positive 9 over 8. And that is one of the solutions. And for this one, I want to do the same thing, subtracting 7 from both sides. But over here, it will again be minus 14 over 2. So that'll give us minus 4x equals. And this time, signs are the same, so we add and keep the sign of the bigger one. And then I have to multiply both sides by minus 1/4. So our x is going to equal positive 19 over 8. And that is the second solution.